Hello, welcome back to Chapter 8, Section 6, where we're discussing radical expressions and showing the relationship between those and exponents that are ratios. And the relationship basically is they're the same thing. So when we talk about exponents, and this is an Algebra 1 skill, so we're going to review Algebra 1 stuff, we have some properties of exponents. And what does an exponent actually mean? And how does that help us simplify when we have things with exponents? So I'm going to do I stole this from the book like I do. And if you look, like all the exponents here are rational numbers. So I'm also going to include, while I talk about this, I'm going to include examples that we would have done in algebra. For example, if I had 5 to the second power times 5 to the 6th power, since the bases are the same, I've got 5 times 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 5. If I write it all out in expanded form, where I write out what I just said, this is going to be 5 to the 8th power. I have 8 of the number 5s being multiplied by themselves. So what this means, this is the product of powers property. There's going to be a lot of p's here. You got the power of a power property, power of a product property. The only word that is quotient. Yep. Alliteration. You know what I'm saying? So for this one, if I have two powers that are being multiplied, I add the exponents. What does that mean in this section? If I have 2 powers that are being multiplied and they have the same base, then I just add the exponents. So 12 to the 1/2 power times 12 to the 3/2 power is going to be 12 to whatever 1/2 plus 3 over 2 is. That would be 4 over 2, which is 2, and then I just keep simplifying from there. The quotient property, if I have 7 to the 9th power divided by 7 to the 3rd power, then this is going to become 7 to the 9 subtract 3 power. So what ends up happening is 7 to the 9th power means 7 times 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 7. That is why we use exponents, so I don't have to keep doing that. And if I divide that by a 7, another 7, and even another 7, then I'm going to end up with 6 of those 7s being multiplied by themselves, also known as 7 to the 6th power. The power of a power property, I knew I'd mess it up. This is if I have an exponent, if I have a power that's a base to an exponent, and I raise that whole thing to another power, then I multiply the exponents. So if I had 4 to the 2nd power, and then I raise that again to the 3rd power, that'd be 4 times 4 once, 4 times 4 twice, 4 times 4 to the 3rd time. So I got 4 times 4 times 4 times 4 times 4 times 4. That'd be 4 to the 6th power. I just multiplied 2 times 6. And I do the same thing if I have these numbers being whole numbers makes it kind of easy to see. These numbers being fractions, kind of hard to see, but they do the same thing. For this one, if I multiply and I put parentheses around it and I raise that to a power, we talked about this earlier, like if I put -3 into parentheses and then raise that, that's the -1 times the -1 times the +3. So I actually have a product there. If I had like 3 times 5 to the 2nd power, this is going to become 3 to the 2nd power times 5 to the 2nd power. This is, and we should just talk about this in class because it's one of those things that causes some problems, but it's not relevant to this section. But this is kind of like distribution, where I'm going to share the exponent with both of these factors. I have had some students, I'll write it down here, try to do something like this: 3 plus 5 to the 2nd power. This does not equal 3 to the 2nd power plus 5 to the 2nd power. Go ahead and try it. All right? 8 to the 2nd power is 64, and 9 plus 25 is 34. These are not the same. So you can't share an exponent over addition, but you can share, for lack of a better way of saying it, an exponent over multiplication. That's because the exponent does mean it's a shortcut for multiplying. So I just want to mention that because if you see something like this, people will do this. X plus 2 to the third power. Oh, that's easy. That's x to the third power plus 2 to the third power. No, it is not. Those are not the same. Back to what we were talking about, though. This power of a product works just like all these. They all work the same if your exponent is a fraction. And the last one, the power of a quotient. So if I had, let's say, 3 divided by 7 and raise that to the fourth power, now that would be 3 over 7 times 3 over 7 times 3 over 7 times 3 over 7. Because when I multiply fractions, I multiply across the numerators, 3 times 3 times 3 times 3, I end up with 3 to the fourth power. And same thing with the denominators. I would multiply 7 times 7 times 7 times 7, and I end up with 7 to the fourth power. All of these are true for whole number exponents. They're also true for rational exponents. So let's do a couple of examples. Now, I got to check things like when I'm multiplying using a product of the power property. See? I have to make sure that I have the same base. 25 and 25, same base. 36 and 36, same base. 8 and 8, 5 and 5. This one, we're going to do something different with that one. We kind of threw this one in there, okay? So we'll get to that. This is going to become this base 25, and I'm going to add the exponent. So I'm going to add 3 over 5 plus 2 over 5. Okay, can I add these? They've got a common denominator. Of course I can add them. This becomes 25 to the 5, 3 plus 2 equals 5, over 5 power. 5 divided by 5 equals 1, so this is just 25 to the first power, or just 25. 36 to the 3/8 power times 36 to the 1/8 power. Same idea. This becomes 36 to the 3 over 8 plus 1 over 8 power. That is 36 to the 4 over 8, which is actually 36 to the 1/2 power. And if I simplify this, this would be the same as the square root of 36, which just equals 6. And we're going to go with the positive root in this case. All right? Just to double check, make sure I'm doing everything I need to do right. I'm still here. All right. Thought I was missing something, but it's okay. All right, I'm going to come back to this one in just a second. I should have thought about that when I put these together. I put these two together because they had fractions. So this is going to be my quotient of two powers property, where I'm going to subtract the exponents. So this becomes 8 to the 1/3 subtract 2/3 power. And that, I can subtract 1/3 minus 2/3 is negative 1/3. Now, we have this and we have that. Okay, so in putting this together, I noticed that these were going to end up being the same, but I wasn't sure if I should just delete one of them. So we'll do both of them, okay? What does it mean when we have a negative exponent? We're going to throw that in here too, but you've already done it. In Chapter 7, Section 1, we talked about negative exponents. So remember, if n is raised to the negative 1 power, and of course n cannot equal 0, this doesn't work if n is 0, this is the same as 1 over n. So remember when we did the powers of 2, we would do 2 to the 0 power, which is 1. Any number except 0 to the 0 power is 1. 2 to the first power is 2, 2 to the second power is 4, 2 to the third power is 8. And then when we filled in our table, we found the reciprocals of everything. This means reciprocal. So this is the reciprocal 1 over 8 to the 1/3 power. And what I'm asking is what number times itself again equals 8? That's just 2. So this is just another way of saying 1/2. For this one, it looks very much the same. I've got -8, 1 over -8 to the 1/3 power. And last time it was what number times itself equals 8. This is what number times itself equals -8. So this is going to be 1 over -2, or you can write -1/2. I don't care where you put the negative sign. All right, for the last one in this example, my base, my exponents are both 5. And I'm going to take 9 over 4 and subtract 1 over 4. I'm going to simplify that and get 5 to the 8 over 4 power. 9 minus 1 equals 8. That's the same as 5 to the 2nd power, which becomes 25. All right, we will see you in the next videos.